Welcome back. Today we want to continue our discussion of matter. And to begin with, let's start with this consideration. Consider the condensation of nitrogen gas, the shattering of a piece of solid carbon, and the combustion of methane, CH4. Which of these is a chemical change and which is a physical change? Okay. Well, let's go back to our concept map and see if we can get into these ideas of changes to matter. We have matter, right? And we said that matter is anything that has mass and volume. And then we came over here and said, hey, there are several types of matter. And the types of matter that we were most interested in were pure substances, and mixtures. And we said that, hey, pure substances have a fixed composition and that mixtures are a blend. And in this blend, each substance retains its properties and identities, right? And we could break down pure substances into elements and compounds, excuse me, and we could break mixtures up into hetero and homogeneous, where homogeneous is a uniform composition and a heterogeneous would be a non-uniform composition. Then we just wanted to talk a little bit about properties of matter. And so we had properties of matter, and we really broke these down into two general types. We said we could have extensive properties, and extensive properties relate to the amount of matter, and intensive properties relate to the type of matter. And then we also went this way and we said, hey, we can have physical properties and we could have chemical properties. And chemical properties relate to the ability of the substance to transform into a new substance. And physical properties are properties we can observe without a transformation. Right? Good. And so now we'd really want to address a new topic, and we want to address changes to matter. Okay, so changes to matter. Let's extend this page. Changes to matter. Let's switch colors too. And there are two changes to matter we want to investigate. We want to consider physical changes to matter and chemical changes to matter. Now, what is a chemical change to matter? A chemical change to matter is a change in matter in which the substance is transformed, that word again, transformed into a new substance. So let's say we have hydrogen gas and it reacts with oxygen gas, and I'll need 2 molecules of the hydrogen gas. It will create 2 molecules of water. Good. Notice I start off here with hydrogen and oxygen elements, and when I'm through, they have combined and they form something new, which is water. That is a transformation. That means the hydrogen has been transformed. That means the oxygen has been transformed into a new pure substance, into water. And so that is a chemical change. And when we talk about reactions, those are chemical changes. A physical change is a change in which the substance does not transform. Does not transform. It changes shape, it changes state, does not transform. Let me finish. There could be a change of shape, could be a change of state, which we'll get into a little later. Could be a change of just the form, but it's form in which it exists, whether it is a chunk or whether it is powder, going from a chunk to powder. That is a physical change because there is not a transformation of the substance into a new substance. Substance does not transform into a new, not a mu, new substance. That's what's important. We are not transforming into a new substance. Okay, there we go. Good. Let's see if we can answer our question now. The condensation of nitrogen gas. What does condensation mean? That means I start off with nitrogen gas and it condenses. It means it ends up as nitrogen liquid. So now the question is there a transformation here? I start off with nitrogen. I end up with nitrogen. Has that transformed? The answer is no. I've changed states, but I have not transformed into a new substance. So condensation of nitrogen gas is a physical change. What about the shattering of a piece of carbon? So let's say I have a really big piece of carbon and I hit it with a hammer, sledgehammer here, yoink, and it's going that direction. And here I am holding the hammer, and here I'm waving at you. And I got strange eyes there and a little hair on the side. Good. So I hit the chunk of carbon, and what happens? I get a whole bunch of little pieces of carbon. I've essentially pulverized the carbon. So the question is, have I transformed the carbon into something new? I started with carbon. I ended with carbon. I've just changed the nature of the carbon. This not the state. I've changed the what? From a big chunk of carbon to a small piece of carbon. I really just changed the surface area of the carbon. So there is no transformation. So shattering carbon is a physical change. Finally, the combustion of methane. Well, what happens in the combustion of methane? Well, methane gas, when we say combustion, usually we mean it reacts with oxygen. And when we have combustion, at least in chemistry, our chemistry, we're always going to assume complete combustion. And when you have complete combustion, you produce water and carbon dioxide and lots of heat. Good. So let's balance this. I've got 4 hydrogens here, so I need to put a 2 in front of here. I have 4 hydrogens. I have 2 oxygens, and 2 times 1 is 2 is 4, so I need 2 oxygens here. So I have 1 methane molecule reacting with 2 oxygens, and what do I create? I create 2 waters and 1 carbon dioxide. Has my methane transformed into something new? Yes. We have a transformation. The methane has become water and carbon dioxide. The oxygen has become water and carbon dioxide with the help of methane. That's a transformation. If it's a transformation, that is a chemical change. Okay? Good. Let's see if you can do one on your own. Consider the reaction of nitrogen gas with magnesium to form solid magnesium nitride. Consider the melting of iron from solid iron to liquid iron, and consider the dissolving of calcium chloride in water. Okay, I'll give you some time to work on this. Okay, let's see what you came up with. The reaction of nitrogen gas with magnesium. Okay, so that means I have nitrogen gas plus solid magnesium. And we said we create magnesium nitride, Mg3 and it's solid. It looks like I need 3 magnesiums to balance this, right? I have 3 magnesiums on this side and 3 on this side. Good. Now, what's happened? I started off with nitrogen and magnesium, and I ended up with something new. If it's something new, what happened? That means we had a transformation. If it's a transformation, what does that mean? Well, that means this is a chemical change. And we should have thought that when we saw the word reaction, right? When you see reaction, think chemical change. Melting of iron. Okay, so I start off with solid iron, and I end up with liquid iron. Has my iron transformed into something new? Well, it's gone from solid to liquid, but it's still iron. So that means there is not a transformation, which means that this is a physical change. Good. And then the last one, this is the toughie. And I think I'm going to need to show you something here for us to understand it. Calcium chloride really is a set of ions. We have calcium plus 2, that means it has a plus 2 charge. And then surrounding that calcium are 2 chlorides. Okay? They're not overlapping, but they're surrounded. So that is calcium chloride, and then that's going to react with our old buddy water. So we have a big oxygen, and on that oxygen we have, did I say react? No, it's not going to react. This is our water. And what really happens when something dissolves? Okay, so let's say it dissolves here. And when something dissolves, at least in water, the ions here, these are ions, are pulled apart and they're surrounded by my water. So what I end up with is I would have a chloride, excuse me, here's my chloride, and that chloride would be surrounded by a couple waters, or not just a couple, many waters. I don't know how many exactly, but it would be surrounded by many waters. And then my calcium, cation it's called since it has a charge, my calcium cation would also be surrounded by some waters. Good. And so this is what roughly it looks like when something dissolves. My ions, that's an ion. My ions are surrounded by my waters. Here's another ion surrounded by my waters. But notice, what do I start with? I start with chloride, and I end over here with chloride. I start with calcium plus 2. I end with calcium plus 2. I start with water, and I still end with water. Did anything transform here? The answer is no. There is no transformation, so that means dissolving is a physical change, not a chemical change. Good. All right, so I hope you understand a little bit about the difference between chemical and physical changes. Let's move on and go to the next consider. Consider the sublimation of carbon dioxide, the boiling of water, and the decomposition of hydrogen peroxide. Are these changes of state? Okay, I mentioned changes of state in our beautiful, yipes, look at this thing, in our beautiful concept map. Changes of state. Right here. Changes of state are a type of physical change, right? Changes of state are a type of physical change, and we want to get into those a little bit in a little bit more detail. And I guess the first place to start is when we talk about states, what do we really mean? We're talking about something that's a gas, or something that's a liquid, or something that's a solid, or something that is plasma. Now, we don't really spend much time on plasma in chemistry. We really focus on gas, liquids, and solids. So when we talk of change of states, that means we're talking about going from one of these states to another. So that means I can go from a solid to a liquid. Let's extend the page again. I could go from a liquid to a gas, and I can go from a solid to a gas, and I can do the opposite. I can go, let's change colors here. I could go from a liquid to a solid. I could go from a gas to, not a gag, I can go from a gas, I can go from a gas to what? A liquid. And I can go from a gas to a solid, right? And those are all changes of states, and they all have names. When they go from a solid to a liquid, we call that what? Melting. When I go from a liquid to a gas, we call that vaporization or vaporizing. When I go from a solid to a gas, we call that sublimation. Excuse me. I can go from a liquid to a solid, we call that freezing. I can go from a gas to a liquid, we call that condensation. And I can go from a gas to a solid, and we call that deposition. Depositing, right? Deposition. And so these are my changes of state. And remember, all these changes of state are what kind of changes? They are physical. Physical changes, not chemical changes. Okay, so let's go and see if we can answer this. Consider sublimation of carbon dioxide. Hey, sublimation. What did we say sublimation meant? It meant I go from carbon dioxide solid directly to carbon dioxide gas. Is that a state change? Yes, it is. It is a change of state. Boiling. That means I start with what? H2O liquid, and when it boils, I end up with H2O gas. Is that a phase change or a change of state? Yes, it is. It is a form of what? Vaporization. You heard me say a phase change. Sometimes we will call these things, instead of states, we'll call them phases. And so we can also call these things phase changes. Are these phase changes? Changes of state. And then decomposition. Decomposition means that my hydrogen peroxide, let's let it be a liquid, breaks down. And we'll assume this time it's going to break down into hydrogen gas and oxygen gas, a complete decomposition. Notice what's happening. I start with hydrogen peroxide. Do I end with hydrogen peroxide? No. I end with hydrogen and oxygen. That means something is transformed. So this is not a state change. This would be a chemical change. Okay? Let's see how you do in your own. Consider the freezing of carbon tetrachloride and the condensation of ammonia. Are these changes of state? Well, freezing. What happens in freezing? Freezing means we go from a liquid to a solid. That means I'd have carbon tetrachloride, which is a liquid, Just an L is what we use there, right? As a indicator. And what do I end up with? I end up with carbon tetrachloride still, but instead of in the liquid state, it is a solid state. Do we have a change of state here? Yes, we do. We call that freezing. Condensation. What does condensation mean? That means I have NH3 as a what? Gas. And when I'm done, I have my ammonia NH3 as a liquid. I start with ammonia, I end with ammonia. They are in different states. Is that a state change? Yes, it is. So the answer here is which of these is a state change? They both are state changes. Okay? Moving on. Only a couple slides left. Here we go. Consider the following experiment. I have aqueous silver nitrate, excuse me, is added to aqueous potassium iodide. Immediately, the solution turns a milky yellow. After centrifuging, the solution separates into a clear, colorless liquid and a yellow solid. Predict whether this is a chemical reaction, whether this is a chemical change. Well, it seems like we need notes again. Oh my goodness, look at this mess. Okay, so let's come down here. Ay, 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 ay. Where can I set this? Okay, we are going to have to take this off of chemical change. Okay, so let's come back up here. See our little chemical change. We want to take a line off of chemical, and we want to bring it down here. Keep bringing it down. Zoink, 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 zoink. And we want to talk about indicators of chem change. Indicators of chemical change. Good. Well, there are 4 things we look for which will give us tips. Now, these are just tips. When I see these things, it doesn't mean that a chem change has necessarily occurred. But if I do see these things, it gives me a good indication that a chem change probably occurred. So number 1, what do we look for? If you see a production of gas, then a chem change probably occurred. Number 2, if you see a production of a precipitate. What is a precipitate? That means a solid forms. Okay, formation of a solid. Number 3, what's another indicator? If you see a color change, then you have probably witnessed a chemical reaction. And number 4, if there is a change in heat. So what do I mean by change in heat? Temperature increases or temperature decreases. If you see any one of those 4, then a chemical change probably has occurred. Now, here's an important thing though. How do we know for certain? To know for certain if a chem change occurs, we must analyze the composition of the substance before and after the change. If the composition is the same, then no chemical reaction has occurred. If the composition is different, then a chemical reaction has occurred. This is the only way to know for sure. These guys here are just indicators. They're just tips. There's still some uncertainty if we see these things. The only way to know for certain is we must analyze the structure. Okay, so We want to predict whether a chemical reaction has occurred. That means we want to look for one of four things, right? We want to look for production of gas, production of precipitate, color change, or change in temperature, change in heat. So what happens here? We have our silver nitrate. It's added to potassium iodine. Immediately, what happens? It turns into a milky yellow. Okay, so what is that? We've got a change of color. After centrifuging, that means I'm spinning it very fast, the solution separates into a colorless liquid and a yellow solid. What is the solid? Hey, that is a precipitate. So, would I predict that the chemical reaction occurred? Yes, I would say a chemical reaction occurred. Why? Because we have a color change and we have the formation of a precipitate. What would I need to do to be certain that a reaction did occur? Hey, for a reaction to occur, what do I have to do? I have to test the composition of my substance before and after, right? If they're the same, then no reaction occurred. If they're different, then a reaction occurred. Okay, here we go. The last slide. This one's up to you. Consider the following experiments. When solutions of HCl, hydrochloric acid, and sodium hydroxide are mixed, the temperature increases. Experiment 2. When solid silver nitrate is dropped into water, a clear solution results. In which of these would you predict that a reaction occurred? Why? Okay, give you some time here. Okay, experiment 1. What do you think? Well, I start off with two solutions, and what happens? We see a temperature increase. Temperature increase, that is what? That's a change in heat, and that is an indicator of a chem reaction. So I would predict that, yes, here we have a chem change, a chem reaction occurring. Good. What about number 2? Does anything happen? Solid dissolves. I go from a solid to a clear solution. Is this an indicator of a chem change? No, this is not one. Remember we said production of gas, production of precipitate, change in color, change in temp. No, this does not indicate that a chemical reaction occurred. So we'd say what? In which experiment would you predict a reaction? Experiment 1. Once again, what would you need to do to determine for sure? Hey, you've got to test the compositions before and after. Before and after. That's the only way we know for sure. If they're the same composition, no reaction occur. If they're different, a reaction occurred. A chem change occurred. Good. All right, that does it for today. Next time, we are going to go into an overview of the periodic table and discuss metals, nonmetals, and metalloids. See you then.